We now explain the exact machining process for selected material examples from each group. The silicate ceramics will be represented by Ceric Tessera and IPS Emax CAD. Zirconia will be represented by Ceric MTL Zirconia. The hybrid ceramics will be represented by Katana Avencia LT and the acrylates by Telio CAD. At first, we have a look at Ceric Tessera, its properties, its indications, and its individual manufacturing process. Ceric Tessera is an advanced lithium disilicate ceramic, a glass ceramic made of lithium disilicate and virgilite crystal structures embedded in a zirconia reinforced glass matrix. Virgilite stands namely for lithium aluminium silicate. The flexural strength in the 3-point test is 550 megapascals and measured by axially is approximately 700 megapascals. The different flexural strength tests are described in the materials module. There is one block size, C14, of the Ceric Tessera, which is usually a sufficient size for all single tooth restorations. Two different translucencies are offered. The HT high translucency blocks are available in the shades A2 and A3. The blocks MT with a medium translucency are available in many shades from A1 to A3.5 and also B1, C1, D1 and bleaching shade 2. Ceric Tessera is indicated for all single tooth restorations from inlays and onlays to crowns. Ceric Tessera is also particularly suitable for veneers. Both in the anterior and posterior region, all indications can be reproduced with Ceric Tessera. There is also a new Ceric Tessera mesoblock so that a tie base can be restored with Ceric Tessera. The special feature of Ceric Tessera is that it can be fabricated very quickly and is therefore excellent for chairside treatment. The restorations are characterized by high aesthetics and they should always be adhesively luted. Conventional cementation cannot be recommended. The Ceric Tessera mesoblock is shown here and the two different possibilities in its application. An abutment can be milled from Ceric Tessera and the supra construction is then constructed on this abutment. It is equally possible to fabricate one piece directly screw-retained crown from Ceric Tessera. This provides the user with a very quick restoration of implants with Ceric Tessera. Here is an overview of the Ceric Tessera manufacturing process with Primel and Speedfire. Tessera is always wet ground and must always be finalized with a glaze. This firing process only takes 4.5 minutes. Ceric Tessera should always be adhesively luted. The Primel Tessera is always wet ground with diamond instruments. This can be done in 3 different milling modes. Please also refer to the milling modes module. In the fast and fine modes, the diamond instruments, diamond 1.4 CS and diamond 1.2 CS are required. In the extra fine mode, the diamond 1.4 CS, diamond 1.2 CS, diamond 1.0 CS, and diamond 0.6 CS instruments are required. Finishing. Slide 54. When producing Cerac Tessera, it should be noted that glazing is not optional but mandatory. This can also be carried out as a glaze firing without vacuum at high speed in the speedfire. Cerac Tessera is stored as a material from software version 5.1.1 or InLab 20.0 and higher. A very practical starter kit is available for working with Cerac Tessera, which contains all the components necessary to start with Cerac Tessera. A brush is included along with the stains, which are sufficient for easy and practical characterization with included stains. The kneading silicone to protect the inner surfaces during a spray glaze is also included. The necessary tools for the firing process, a glass fiber mat, and the honeycomb are also included. The glaze spray must be ordered separately as it is not included in this kit. Cerac Tessera is a silicate ceramic, and accordingly the process of silicate ceramics also applies to Cerac Tessera. It is therefore important to ensure that the removal of the tapping point is carried out as wet as possible with a fine-grained diamond. Carbide burrs are not suitable and should not be used. If the work can only be done dry, special stones should be used that are especially suitable for working on ceramics without heat development. The company Meisinger offers some instruments for this purpose. Other manufacturers, such as Eve, also have instruments that are recommended for dry processing of ceramics. After processing, the restoration can be cleaned with a steam jet. However, cleaning can also be done under running water with a toothbrush. It should be then disinfected with alcohol. Glaze firing is absolutely necessary and required for Cerac Tessera in order to achieve the specified strength values. You have the choice between spray glaze and stain and glaze with universal colors. In order to actually keep the glaze time for Cerac Tessera below 5 minutes, it is necessary to preheat the speedfire to 400 degrees. To do this, press the thermometer button at the bottom left of the display as shown here in the photo. This will preheat the furnace to 400 degrees and hold this temperature for 30 minutes. In the practical workflow, the speedfire is to be preheated the moment the restoration is removed from the prime mill. Before you start with the glazing of the restoration, it is advisable to dry practice once to see how the restoration should be and can be stored later in the speedfire. This always depends somewhat on the shape of the restoration. As shown here in the photo, it makes sense to store anterior restorations on the investment pin. This is done without stabilizing paste. Crowns in the posterior region and flat restorations can be placed on a glass fiber mat on the honeycomb. The important thing here is that one of the two options must be made possible in order to be able to carry out the glazing. There are two different sizes of these embedding mask pins available. We have the smaller blue pins and the larger pink ones. This means that small anterior crowns can be placed primarily on the blue pins. In the posterior region, the large red pins with a contact surface are more suitable for larger and flatter restorations. This shows how the CEREC Tessera restoration may be positioned. This positioning is important so that the restoration is later positioned exactly in the heat center in the speedfire combustion chamber. Either an investment pin is to be used or the restoration is placed on the glass fiber mat on the honeycomb. An investment pin must never be used together with the glass fiber mat and the honeycomb. Both separately are placed on the upper door seal. Please do not use both together. Once we have tried out how the restoration will be stored, we can start with the actual glazing. Here we can work with spray glaze or with universal stains. If we want to characterize the restoration, first the inner surface is protected from the glaze with this kneadable silicone, which is included in the starter kit. Stains can now be applied, not covering the entire surface, but only in the areas where characterization is desired. Once this has been done, the spray is applied. As already described for zirconia, an even film is applied to the crown surface after the sprays have been thoroughly mixed. A short wait is made for the solvent to evaporate, and then a second coat can be applied. Here again, as a reminder, it is important to shake the spray well before application. Once the glaze is ready, the silicone putty must, of course, be removed from the inner surface of the restoration before the restoration is subsequently glazed in the kiln. As shown above, the restoration is now placed either on the honeycomb or in the investment pin, as we tried out before starting the glaze. This makes sense so that the glaze is no longer heavily stressed or damaged at this moment. The speedfire has already been preheated before the glaze firing is now started. The restoration is placed on the upper door seal, either on investment pin or on the honeycomb, and the program is started. When the speedfire is preheated, this only takes 4.5 minutes, which is amazingly, blazingly fast. After completion of the glaze firing, it is important not to touch the restoration directly with the cold tweezers, but to either grasp the honeycomb with the tweezers or to grasp the investment pin with the tweezers and therefore place the restoration on the fan area in the front of the speedfire. It is essential to ensure that the program in the speedfire is completely finished before the restoration is removed. The cooling time of 2 minutes must be strictly observed. We even recommend to let the restoration cool down to room temperature for another 5 minutes to avoid any accidents. Let us now turn to the well-known material IPS Emax CAD. Let's take a look at the properties and indications as well as the processing procedure. Emax is a lithium disilicate ceramic and therefore a glass ceramic. Emax is wet ground in the blue state. This is an intermediate crystalline stage. In this stage, Emax has a low hardness of approximately 130 megapascals. After the mandatory crystallization of the material in the kiln, it has then reached the corresponding tooth color and its final hardness, which is 530 megapascals in the 3-point test and approximately 360 megapascals in the biaxial flexural strength test. The indications for Emax are very broad. They range from single tooth reconstruction both in the anterior and posterior region for all indication areas to inlay, onlay, veneer, crowns, and also abutment crowns. Here, both directly screw-retained crowns can be created as well as abutments on a tie base. Bridge blocks are available. It should be noted here that the bridges are only released up to the second premolar and should not contain more than one pontic. This is an overview of the workflow with Emax. We have the wet grinding. Then either the blue phase can already be glazed and characterized so that only a joint crystallization and glaze firing can take place. However, it is also possible to conduct another glaze firing after the crystallization of the material before the restoration is finalized and has to be adhesively luted. With the prime mill, Emax is always wet ground with diamond instruments. This can be done in 3 different milling modes. Please also refer to the milling modes module. In the fast and fine modes, the diamond instruments Diamond 1.4 CS and Diamond 1.2 CS are required. In the extra fine mode, the Diamond 1.4 CS, Diamond 1.2 CS, Diamond 1.0 CS and Diamond 0.6 CS instruments are required. Here again, as a reminder, the blue phase is an intermediate stage. Wet grinding is always necessary and wet finishing is definitely recommended. As already mentioned, crystallization is mandatory, which is also indicated by the blue color of the material which has not yet crystallized. A particularly fast crystallization is possible in the CS6 with a time of less than 12 minutes. In Ceric Speedfire, this process takes with about 30 minutes significantly longer. In principle, the same applies here as for silicate ceramics, namely that the dry processing should only be carried out with special instruments. Carbide drills should never be used and wet processing of the restoration is absolutely recommended. Cleaning is also done here with a steam jet or alternatively under running water with a toothbrush. Disinfection is done with alcohol. The glaze after the crystallization would be optional as the application of a glaze mass is not mandatory. In principle, the restoration can of course also be done with a spray glaze or with stains. Here it is important to say again that Emacs can be painted and characterized and glazed with all universal stains that are CTE neutral. It is common to use the original Emacs colors for staining and glazing. But please note that these Emacs colors may not be used on other materials. They can only be used for Emacs. It is of great importance that for the crystallization firing, when the restoration is still blue, Object Fix should be used exclusively for this stabilization. The use is mandatory and all margins must be supported. This means that Object Fix must really be applied over the entire inner surface and completely fill it up to the edges. It should also not protrude beyond the margins, but it should be flush with the edges. Object Fix has an important meaning because it stabilizes the restoration during the crystallization process in the kiln. Care must be taken that the pin does not touch the ceramic. As shown in the picture, Object Fix should actually cover and support the entire inner surface of the restoration very precisely. Here, the two optional processes are shown once again. The blue phase can already be finish stained, characterized and glazed. Or the crystallization firing is conducted first and the individualization and glazing can then be carried out on the tooth-colored restoration. This approach requires a second glaze firing turn. Let's just move on to the workflow for Ceric MTL Zirconia, its properties, indications, and the individual manufacturing process. The properties of Ceric MTL Zirconia are summarized once again here. It has a highly translucent zirconia with a color gradient included. The flexural strength of 850 megapascals is present in every shade layer. The special feature of Ceric MTL Zirconia is that it is particularly fast in production and is therefore especially suitable for chairside treatment. It may only be milled dry and the minimum wall thickness is 0.6 millimeters. Here you can see once again in detail how thick the minimum wall thickness may be for MTL zirconia restoration. This is generally 0.6 millimeter occlusally. Posterior bridges should have an occlusal minimum layer thickness of 0.7 millimeter. Both as well provided that the restoration is adhesively luted. The connector cross sections for bridges in the anterior region may be 9 square millimeter. For bridges in the posterior region, this should be 12 square millimeter. The indications for MTL zirconia are wide-ranging. It is possible to make veneers with this material, partial crowns, and of course, bridges. There are no contraindications for the use of posterior or anterior teeth for single tooth restorations and for bridges, mostly only one pontic can be fabricated. The size of the firing chamber of the Speedfire and the size of the available blocks for the prime mill are more of limiting factors. Here is the workflow for Ceric MTL Zirconia at a glance. Dry milling is absolutely recommended and only possible. The subsequent sintering process is essential and mandatory. The individualization and processing of the finished sintered restoration can optionally be done by polishing or by glazing. Adhesive luting is always preferable. Dry milling can be done in under 5 minutes in superfast mode. In fine and extra fine mode, the production takes a little longer. More information about the milling modes can be found in the so-named module. The carbide cutter combinations for dry milling of zirconia for prime mill are shown here. Here you can see that in superfast milling mode, each side is equipped with the same cutters to ensure particularly fast processing. This slide shows the instruments for the Ceric MCX and MCXL. Milling in superfast mode is not possible here. The white restoration before the sintering process is very soft and like a sponge. Therefore, it is imperative to protect it from contamination, especially from grease and silicate particles, and therefore it may only be touched with gloves and should only be processed dry. Cleaning should also only be done dry. Under no circumstances should the pre-sintered white restoration be steam blasted or sand blasted. The unhealthy milling dust should be carefully removed with a dry brush, or dry compressed air can be used to clean the restoration. The tapping point should be leveled with a fine-toothed carbide cutter instrument not exceeding 10,000 revolutions per minute and always dry without water cooling. The surface of the white unsintered zirconia crown should be treated very carefully. Polishing is quite possible in this condition, but we don't recommend it. Care should be taken not to work with too high rotations. An interesting option is to carve the surface with special instruments. For sintering, the restoration is always placed on the occlusal surface, on the upper door seal of the speedfire. Make sure that there is no other material in the speedfire. Just place the restoration without speed paste, other stabilizing paste, support pins or glass fiber mats, simply with the occlusal surface on the naked upper door seal. After the sintering process, the restoration is now very hard. In contrast to the non-sintered restoration, it is absolutely necessary to work only wet in order to avoid heat development on the material. The now finished teeth-colored restoration can either be polished only or it can be stained and glazed. This can be done with spray as well as with universal stains. For glazing, we use Ceric speed paste to fix the glaze support pins. After staining or spray glazing, the restoration fixed on the glaze support pin is now placed in the speedfire and the glazing program is started. We will not go into the exact painting and polishing process again at this point. We have described it in this module very precisely and generally for all zircons, and these descriptions also apply to Ceric MTL zirconia. Now we show Katana Avencia as a representative of hybrid ceramics with its properties, indications, and manufacturing process. Katana Avencia is a composite-based material with particularly well-compressed nanofillers, giving it a very strong and stable structure. Among the properties, the special hardness of Katana Avencia with over 220 MPa should be emphasized. Competitors from the same material group only achieve these values to some extent. Lava Ultimate and Cera Smart are roughly in the same hardness range. One characteristic of Katana Avencia is its particularly good polish ability, which is due to its structural composition. This polish is of high stability and long-term durability. Studies have shown that Katana Avencia is particularly wear resistant and kind to the opposing enamel. The indications for Katana Avencia are more likely to be in inlays and possibly onlays and particular crowns. Full crowns should be made in the anterior region and perhaps for premolars. There are stronger and more suitable materials for the posterior region. Katana Avencia is available in 2 block sizes. We have blocks of size 12 and blocks of size 14L. Both are available in 3 shades, A2, A3, A3.5, each in only one translucent LT. That means in low translucency. Here we show an overview of the manufacturing process. This manufacturing process is short and simple because Katana Avencia is not allowed to go into the kiln because it is a composite-based material. It must be wet ground and then polished either with goat hair brushes and polishing paste or with conventional silicone polishers. Adhesive luting is absolutely recommended. With the primal, Katana Avencia LT is always wet ground with diamond instruments. This can be done in 3 different milling modes. Please also refer to the milling modes module. In the fast and fine modes, the diamond instruments, diamond 1.4 CS and diamond 1.2 CS are required. In the extra fine mode, the diamond 1.4 CS, diamond 1.2 CS, diamond 1.0 CS and diamond 0.6 CS instruments are required. Once again, it is important to point out that hybrid ceramics, also Katana Avencia, must never be put in the kiln. Otherwise, the material would melt. If individualization is desired, special composite colors are available for this purpose. However, in clinical use, the material shows an amazing chameleon effect that makes staining particularly unnecessary. As a representative of the acrylates, we describe TeleoCAD with its properties, indications, and processing procedure. TeleoCAD is a polymetal metacrylate resin and has a flexural strength of 130 MPa. The indications are long-term provisionals. Single crowns as well as bridges can be fabricated. The restoration of a tie base is also possible. This means that implant-supported long-term temporaries can also be fabricated. Here is the overview of the workflow. Wet milling is recommended, and only polishing is done afterwards. Long-term temporaries are usually only cemented temporarily. Special aesthetic resin-based temporary luting materials are also available for this purpose. But conventional temporary cements such as Tempont can also be used. Here, it is important to ensure that the material is eugenol free. With the Primal, the best manufacturing mode for PMMA is wet milling with carbide cutters. This can be done in 3 different milling modes. Please also refer to the milling modes module. In the fast and fine modes, the burr 2.5 PMMA and burr 1.0 CS are required. In the extra fine mode, the burrs 2.5 PMMA CS, 1.0 CS and 0.5 CS are required. From the team at Fit for CEREC, we would like to say thank you, and we hope you enjoyed our presentation.